Hi there. We're continuing our work with the Fundamental Theorem of Calculus Part 1. We're looking at taking the antiderivative and using the bounds to help us evaluate a definite integral. So let's take a look at these functions that I have here. I think these are going to be good practice for us as we're getting acclimated to, yes, I need to find those antiderivatives and then I need to use my bounds to help evaluate. And then we'll finish up in this video with working from a chart because a lot of times we know AP is going to give us chart questions where we have to apply the fundamental theorem as well. So let's start with the definite integral from -1 to 2 of 2x minus x cubed. So remember, the first thing we want to do is to start with the antiderivative. So the antiderivative of 2x would be x squared minus, and the antiderivative of x squared would be 1/3 x cubed. Remember, if you want to write it as x cubed over 3, that's no problem. You can do that. But we want to use our bounds, and the top bound goes in first. So we substitute in the top bound, and then minus, and we put in, I'm going to put a parentheses, and now we put in the lower bound. All right, so 2 squared would give me 4, minus 2 cubed is 8. 8 times 1/3 gives me 8/3. Minus, and then I have -1 squared is 1. -1 cubed is -1 times the -3rd gives me 1/3. You may want to go ahead and distribute that negative. So I end up with 3 minus 9/3, which is 3, which gives me 0. So let's keep going. So I'm going to rewrite this one here. I'm going to rewrite that as the definite integral from -2 to 3 of x to the -2 plus x. Rewriting it so I can see the power of the exponents that I need to use. So I'm going to increase the power by 1, put it over the new power, and then the antiderivative of x would be 1/2 x squared. Don't forget your bounds. I'm probably going to rewrite my antiderivative before I start plugging in. Want it to be as easy as possible when I do plug in. Okay, so let's plug in 3. I've got -1/3 plus 1/2 times 3 squared minus, now watch this, I've got a -1 over a -2, so that gives me a positive 1/2 plus 1/2 times -2 squared. Okay, so I've got -1/3 plus 9/2. Then I've got minus 1/2 plus -2 squared is 4 times 1/2 is 2. Okay, so it looks like I've got -1/3 plus 9/2 minus 1/2 minus 2. So I've got -1/3, crunching out some numbers here. 9/2 minus 1/2 gives me 8/2. That's 4 minus 2. So it looks like I've got 2 plus a -3rd. That would be 5/3. Crunching out some just fraction work there. Okay. Now on this one, I think it's a good example. We see this problem quite often in AP problems. We're going to split this into two integrals. Actually, I'm going to split it into two fractions. Let's do that first. That might be easier. I just undid a common denominator. This was basically what I was doing there. And the reason I do that is so that it'll make the antiderivative a little bit easier. Now, the antiderivative of 2 over x, I want you to think of this as 2 times 1 over x, because the antiderivative of 1 over x is ln of x. Then over here, I'm going to increase my power by 1 and put it over the new power. Oops, I was almost put a plus c there, but we are dealing with a definite integral. So I've got 2 times the ln of absolute value of x minus 3 over x. Now I'm putting in 1 and 4. Now I have to put the absolute value on the ln of x because the ln can't handle a negative, but we do see in our area here that we're not going to be dealing with any negatives, so I'm going to drop that. So I'm going to put 2 ln of 4 minus 3/4, then minus parentheses 2 ln of 1 minus 3. So don't forget the ln of 1 is 0. So we're left with the 2 ln of 4, and then let's add negative 3/4 plus 3, and that would be 9/4. And we'll leave it there. Okay, then let's do a trig function. So antiderivative here is x squared plus sine of x. Now let's plug in our values. So we'll put pi squared plus sine of pi minus 0 squared plus sine of 0. So I've got pi squared. Sine of pi is 0 minus 0 minus sine of 0 is 0. So we end up with pi squared. Nice there. And I apologize. My cat thinks she owns the place here. So I apologize for that. Now let's finish up today then with some table work. Okay, because sometimes we do see these questions pop up. Notice in this one, we're given lots of information about the function, the first derivative, the second derivative, all different values of x. We want to find the value of the antiderivative, the integral from -3 to 1 of f prime. So the antiderivative would be f of x, and we're going from -3 to 1. Remember, we plug in the 1 first. We have f of 1 minus f of -3. So f of 1, get from the chart, is -2. And f of -3 would be 4. And so I get -6 there. Is it okay for our integral to equal a negative number? Yes, that means that our area is located below the x-axis. Totally fine. Up until calculus, you probably thought area couldn't be negative, but now you know it can be. All right, let's look at number 2 then. We need the antiderivative of f prime. That will be f of x. And the antiderivative of f double prime will be f prime of x. Still going from -1 to 3. So we're going to have f of 3 plus f prime of 3. Then I've got minus f of -1 plus f prime of -1. Notice the parentheses around the second portion. Very, very important. So f of 3 is 1. F prime of 3 is 3. F of -1 is 0. And f prime of -1 is 1. And so you've got 4 minus 1 gives us 3. Okay, let's look at number 3 here. What is the value of the integral from 1 to 5 of 3 f double prime? Okay, well, the antiderivative will be 3 times f prime of x. And we're going from 1 to 5. Now plug in your value, 3f prime of 5 minus 3f prime of 1. And now you can get your values from the chart. So f prime of 5 would be 2. And f prime of 1 would be 0. So we get 6. Okay, let's look at number 4 then. This is getting busier, right? Okay, so the antiderivative of 1/2 f prime would be 1/2 f. And the antiderivative of 2f double prime would be 2f prime. And we're going it from -3 to 3. So I've got 1/2 f of 3 plus 2 times f prime of 3 minus 1/2 times f of negative 3 plus 2 times f prime of negative 3. Okay, so f of 3 is 1, and f prime of 3 is 3. And then I've got f of negative 3 is 4, and f prime of negative 3 is negative 2. Okay, so I've got a half plus 6 minus 2 plus negative 4. So this is negative 2. So I've got a half plus 6 minus negative 2. So that's plus 2. So that gives me 8. 8 plus a half, 17 halves there. Okay, 2 more to go. So let's look at number 5. What is the equation of the tangent line of f at x equals 3? Oh, this is a good throwback. This doesn't have anything to do with antiderivatives. So we need a slope and a point. We get the slope from f prime of 3. F prime of 3 from our chart is 3. My point is at 3 f of 3, which is 3 f of 3 is 1. So now you got your point and your slope. You can write your tangent line. Y minus 1 equals 3x minus 3. Then number 6. Number 6 says, okay, use the equation of the tangent line in number 5 to write an approximation for f of 3.1. So this is saying if you had to use this line as your function and x was 3.1, what would you get? So I'm going to put in 3.1 here for x. I got y minus 1 equals 3 times 0.1. So y minus 1 equals 0.3. So y is 1.3. So f of 3.1, remember, it's not equal, it's approximately 1.3. And this is saying, is it an overestimate or an underestimate? This is a tricky one, okay, because we don't know a whole lot about the function. We only know what we have in the chart. But I want you to see, look at f of 3. I want you to see that it tells you that f double prime of 3 is negative. Do you see that f double prime of 3 is negative? When we know that the second derivative is negative, we know the curve is concave up, something like that. So if you have a tangent line that you are using to approximate a value on the curve, which is higher, the curve value or the tangent line value? The tangent line value is lower, so that means the curve is higher. That means that our tangent line is an overestimate. I'm sorry, this is an underestimate, forgive me. And it's because f double prime at 3 is negative, which makes the curve concave up, which means my tangent line is below the curve, which means that my tangent line is too low. The estimate I get from my tangent line is too low. Now, we'll do more of the over and underestimate practice because I know you're kind of like, I don't know about that. We'll do more for sure. No worries on that. But thanks for watching for the antiderivative, the fundamental theorem practice. This has been really good. If you need some help further, please let me know in the comments below. I would love the opportunity to help you. And don't forget to hit that like and subscribe button. See you. Bye-bye.